Hello there, welcome to the ASFM, the Maths Core June 2023. Here we're looking at question 9. We have a matrix P here. Show that P is non-singular for all real values of K. So a non-singular matrix is a matrix where you can find an inverse, where the determinant is never 0. So I imagine this question is all about finding the determinant of P and showing that it can never be 0. So let's find the determinant. So it's going to be equal to K times, cross out the row, cross out the column, matrix of minus will be minus 20 minus 2k. When it's the middle term, remember by our matrix of cofactors, we need to multiply it by a negative. So it's minus minus 2, which will make it plus 2 times minus 12 minus 2k. And then add 7, lots of minus 3k. And then minus 4k, so that would be plus 5k, and so overall that would be 2k. Okay, expand the bracket, so it would be minus 2k squared minus 20k minus 24 minus 4k, add 14k. So the determinant here is going to be minus 2 squared minus 24, add the 14 and be minus 10k minus 24. Excellent. Now to prove that a quadratic has no solutions equaling 0, we need to prove our discriminant is negative. So b squared minus 4ac is going to be minus 10 squared minus 4 times minus 2 times minus 24. So let's work this out. It's going to be 100 minus 4 times 2 times 24. Triple negative will keep it a negative, so that would be minus 192. So that would be minus 92. And then we'll conclude as b squared minus 4ac is less than 0. Minus 2k minus 10k minus 24 equals 0 will have no solutions. Now we need to link it into the non-singular parts of the question as P as the determinant of P cannot equal 0, the matrix P is non-singular. And there we are, that's the answer to part I. Moving on to the next part now, we have a matrix Q, which is 2 minus 1 minus 3, 0. The matrix Q represents a linear transformation T. Under T, the point A, which is A2, and the point B, which is 4 minus A, where A is a constant, are transforms to the point A dash and B dash. Given that A dash and B dash, so the distance between A dash and B dash is root 58, determine the possible values of A. Alright, so let's take matrix Q and transform these coordinates. So it's going to be A2 and 4 minus A. You could have done them separately, but you can do them together as well. Multiplying these matrices together, we get 2A going across and down, minus 2. 8, add A, minus 3A, add 0, and minus 12, it's just minus 12. Okay, so our coordinates A dash is here and B dash is here. Now, so let's treat these as if they were vectors. So it's 2A minus 2 and minus 3A and B dash, which is 8 plus A minus 12. If we wanted to go from A dash to B dash, we would do B dash take away A dash, which is 8 plus A minus 12, take away 2A minus 2 minus 3A, where we get 8 minus minus 2 is 10, A minus 2A is minus A, minus 12 take away minus 3A is 3A minus 12. Right, now we know that the magnitude of this distance is root 58, so it's going to be, we've done a question like this already this video, the distance of 10 minus A squared add 3A minus 12 squared is equal to root 58. So we'll cancel out the square roots on both sides, and then we're going to expand these brackets. 100 minus 20a, add a squared, plus 9a squared minus, it's going to be 36, double it, 72a, add 144 equals 58. Let's create a quadratic here, so it's going to be minus 92a, and then if we move everything onto the left, we're going to get 100, add 144 minus 58, so we'll get us plus 186 equals 0. We're going to reach for our calculator now and work out the solutions, and when we type them in, we get 3 and 31 over 5. Do we cancel out either of these for the possible value of a? I can't see why we would cancel out either of these two values. A is a constant, transformed. No, I think both of these two values are valid. So there we are. That's the answer for question 9, worth a total of 9 marks. Let's now move on to question 10.